Hello and welcome to today's video. Today's video is for advanced geometry. It is chapter 3, section 4, parallel lines and the triangle angle sum theorem. So this section starts out with a theorem, the triangle angle sum theorem, and this one says that the sum of the measures of the angles of a triangle is 180 degrees. And you might ask yourself, why is this in with parallel lines? And the reason it is because the proof actually involves parallel lines. So I am going to do this theorem this proof in class, but I want you to take a look at it, and there's something I want to point out to you. Notice what they did. They took a triangle ABC, and then they drew this line up here, which we could call line PC. And when we use this line, we're actually going to say that that line is parallel to AB. So this proof is actually going to involve a construction. And you need this construction to be able to do the proof. Now, once we get into constructing something on any given, you have to be careful that you have to be able to construct something that you could always construct for any triangle that was given. Okay, so if I take any triangle that I could be given, ABC, I could always construct a line that went through C and was parallel to AB. So this would be a valid construction. Now, you don't have to get out your construction tools and actually construct it. You can just draw it in your diagram, and then you can actually use it as a given. One of our givens will say construct line PC parallel to AB. Okay? Now you can't get crazy with construction and say, hey, construct line PC and make it parallel to AB and make it perpendicular to this. It would have to be something that would work for any given triangle ABC. Okay? So we'll talk about that more in class, and we'll do the proof. So this example has us applying the triangle angle sum theorem. If you take a look at the diagram, we actually have three triangles. We have triangle FGJ, and then we have triangle JGH, and then we also have a big outside triangle FGH. Okay, so what I'm going to do is I'm going to take a look and see what I can get. I really can't work too much with the right triangle because there's two unknowns in that one, but I can work with the left-hand triangle, and if I take 39 and I add 65, and I add x, that should equal 180 degrees. And if I add these together, I get 104 plus x equals 180. And if I subtract the 104 from both sides, I get x equals 76. Okay, so x is 76. And then probably the easiest thing to do is not even to use triangles at this point. X and y have to be supplementary. So that angle right there, y must also be 104 degrees because it's supplementary to that 76. And then we can also use the big outside triangle to get z, because if you take a look at the top part, this angle right here would have to be the 21 plus the 39. So that's going to be 60 degrees. And then we also have the 65 down here. So if I take 60 and I add 65 and I add z, that equals 180. And I can add these together and get 125 plus z equals 180. Subtract the 125 from both sides, and z equals 55 degrees. So z equals 55 degrees, and I have them all. The next thing we have are some triangles. So if we have a triangle that's called equal angular, it means all the angles are congruent. So I can draw a triangle up here. And if I make all of these angles congruent, then it's going to be equal angular. If all the angles are acute, then it's called an acute triangle. So it doesn't have to be equal angular. So I'll try to make something that doesn't quite look equal angular, but still looks like they're all acute. So I'll put all angles acute, and that's an acute triangle. If it has a right angle, then it's called a right triangle. So if I draw a triangle and I put one you can only have one right triangle or one right angle in a triangle. So if I have a right angle, then it's called a right triangle. And if I have an obtuse angle, then it's called an obtuse triangle. So each one of these deals with angles in the triangle, and then the next row deals with sides. If all the sides are the same or congruent, then it is called equilateral. Lateral comes from that word lats. So if you've ever been in the gym and done your lat raises, it means sides. So equilateral means all equal sides. One thing to note is in a triangle, this doesn't work for other figures, but in a triangle, if all the angles are the same, all the sides are also going to be the same. So a triangle that's equiangular will always be equilateral, and a triangle that's equilateral will also be equiangular. Okay. Isosceles means it has at least two congruent sides. So according to our book, if it is isosceles, if it is equilateral, it is also isosceles. Okay. It just has to have at least two congruent sides. And then if it has no congruent sides, so none of these sides are of equal length, then it is called scalene. So we can actually combine them. We could have, a scalene obtuse triangle. We could have a right isosceles triangle. So it doesn't have to be one of these. You can do a combination of them. So if we take a look at this picture, classify it by its sides and its angles. If I take a look at the sides, it's isosceles. And if I take a look at its angles, it looks like they're all acute. And so I will say isosceles acute triangle. Because they're obviously acute, I can say that it's acute. If it looks like it might be right, you have to be careful. It have to be labeled as right. If it looks like it's right, it could be acute, it could be obtuse. We're not totally sure. Now, we're going to have another theorem, but in order to do that, we have to have a definition. So the exterior angle of a polygon is an angle formed by a side and an extension of an adjacent side. So if I draw a triangle, so an angle formed by a side, so maybe I'll pick the bottom side, and an extension of the adjacent side. So if I take one of these other sides and I extend it, then this angle right here would be an exterior angle. Now, remote interior angle. So I have my exterior angle. The remote interior angles, there's always going to be two for any exterior angle, are the two non-adjacent interior angles to the given angle. So if you take a look at my exterior angle, the adjacent angle would be this angle right here. So I can't include that one. If you take the other two, they're remote interior. So this would be a remote interior, this would be a remote interior. So these would be remote interior angles. Okay. And depending on where the angle is, it's the same thing. It just can't be the one that's adjacent. It's the other two angles of the triangle that are not adjacent to that exterior angle. Okay. So now we have a theorem. Triangle exterior angle theorem says the measures of each exterior angle of a triangle is equal to the sum of the measures of its two remote interior angles. So if you take the measure of angle 1, it is equal to the measure of angle 2 plus the measure of angle 3. Okay.
Pardon the interruption, would Sean Nicholson please report to the Commons? There's a parent waiting for you. Thank you.
And this one we can prove using supplementary angles and the triangle interior angle theorem. And we'll do that one in class. So this ends today's notes. Thank you for watching. Have a great day.